Hi to all. Today's video is about a private Docker registry as a Kubernetes pod, which we do need in order to be able to use our custom Docker images with our Kubernetes cluster. I tried a lot of different variations that didn't work, and the only thing that did work in the end was to set up the registry as a pod within Kubernetes. In the beginning, I want to delete an image from the registry and push it again in order to demonstrate with the script how this works. And after that, I will explain how we can set up the whole thing. The script is this one here at the left side: delete image from registry and push it again. So these are my variables: reg image, tag, image tag, auth, and auth, and also accept, so that the script is a little bit cleaner. And the first thing we're doing is we run cur delete on the hash value digest, because we need that in order to be able then to delete the blobs. So curl x delete over here, and then we need this command substitution. And then deleting blobs by calling the bin registry garbage collect. And once we do this, we do have to delete the remaining files under var lib registry, docker registry, version 2 repositories. Delete the image folder that's left over. Then we ls repositories, and we try to push the image again over here, and query repositories in the end. The thing with deleting and then pushing again, it's a little bit tricky because I'm going to explain later on how we deactivate the Docker registry's cast function, because it's buggy and it won't let us push the image we just deleted. An error is thrown at us that the image exists and we can't push it anymore. Okay. So first thing I want to do is resume the VMs. Okay, the VMs are resumed now. The VMs are 3 Ubuntu LTS KVMs, and the VM host is also Ubuntu LTS, the latest. And over here I got my control plane. As you see over here, pod, docrec pod, that's the registry pod. Also got Grafana installed, but that's not working yet. Okay, and now I want to run the script, delete from reg standalone. So cur delete on the hash value, and delete here manifest, and I've got my hash value. And over here I got an exit code 202, which means success. Then delete blobs. Blob eligible for deletion, deleting blob everywhere the same, so that worked as well. Then ls repositories are empty now, and push again the deleted image mubu 7. So I'm pushing the image again. It's working. Right, and after that we want to query the repositories again. Right, so query the repositories again, and as we can see, mubu 7, it's again in the repository, so this has also worked. Now I want to explain how all this is done, and over here, I could start by explaining a little bit about the configuration file of the registry. So with kubectl exec and so on, I drop into the pod, and then cut the configuration file, which is this one. But the thing is, okay, I have to pause my VMs first. The thing is that when we set this up as a pod, here is the pod YAML. And here we set up as environmental variables or our secrets, keys, and certificates, and so on, for this to work. But when we do that, actually we disable then the registry's configuration file. So any configuration we want to undertake, it also has got to be written here as environment variable. So the first thing is registry storage delete enabled in order to be able to delete images from the registry, set to true. And registry storage cache blob descriptor, which I was just saying about the buggy cache function. So we leave this empty, and thus we disable it so that we don't get an error when we trying to push again a deleted image. In order to set this up, we need quite a few steps with authentication, configurations, keys, certificates, and so on. And we're starting by creating TLS certs with OpenSSL rec. We need a new key, RSA, key out, and add text, and X509, as you see over here. After that, we'll create Docker HT password, and with Docker run rm entry point, HT password registry. Now, this is a little bit tricky because I haven't used the latest image. And the reason is I used the one before the latest, and the reason is because sadly the latest registry image does not work with HT password, so that's why we're doing this. As you see over here, these are then usernames, username and password, which then are used in HT password. That's how my registry directory then looks. Then we have to create secret in order to mount the TLS certificates and that are used in the YAML of the pod. So we need to create a secret TLS cert secret with a certain key. The same thing we have to do, but this time with secret generic for the HT password from file registry auth HT password. Then we have to resolve the service IP. I'll show you then after that the YAML also for the service. So the pod works with a service, and we should add this to etc. hosts on all our nodes. Then we have to copy TLS cert as shown below so that it is trusted by Docker. And this is, we're doing this procedure over here because this is a self-signed certificate, and otherwise this whole thing won't work. And then the last directory must be in this format, the name of the registry, colon, and port number. 5000 is default in this case. and where TLS cert and KCert are these ones over here. And we're doing this with a for loop also on all nodes. Then after that, we try to log in with our credentials, which, like I said, I use my name for username and my surname for password. And if successful, the login credentials are stored then in root docker config file. And the last thing we're doing is to create a Kubernetes secret to use for pods to authenticate, which we can either do with kubectl create secret docker registry, and we have to use then docker server and username password like that, or we can create a secret generic. That's then how I name it, recred, and we use the file we just created when we logged in the previous step, the configuration file. So that's how it works, and then we incorporate all of that here in the pod as environment variables, as you see over here. We have them here also certs and auth as volume mounts along with our varlib registry path, which is also default. And then we have our persistent volume claim. It's over here. We do a persistent volume and persistent volume claim, and with match labels type PR store, and over here also have PR store. That's how they're connected. Right, and that's over here. That's the service. So that's how it works. So you can use all your custom images without any problems with Kubernetes. I hope you enjoyed this video. Thank you very much for watching, and see you at the next video.